Section 8.1, interior and exterior angles in polygons. Take a look at what we have here. You now know them as a triangle, quadrilateral, pentagon, and hexagon. A triangle has 3 interior angles. Quadrilateral has 4, a pentagon has 5, and a hexagon has 6 interior angles. And what we are going to find out, we're going to do some calculating, that the sum of the interior angles of any polygon, we're going to focus only on the interior angles right now, of any polygon has a formula, and yeah, it has a little subscript I, don't let that panic you. It just says sum of the interior equals parentheses n minus 2. N will always stand for our number of sides. I feel like in algebra we always use x for everything, and now we're using n. Number of sides minus 2 times 180. So if I wanted to add up how many degrees there were in a triangle, I could take 3 minus 2 times 180. We already knew from prior knowledge that there are 180 degrees in a triangle. If I want to know how many degrees there are in a quadrilateral, 4 minus 2, 2 times 180 is 360 degrees. How many are in a pentagon? 5 minus 2 times 180. 3 times 180 is 540 degrees. Notice I put the degree symbol on it every time. And in a hexagon, 6 minus 2 is 4. 4 times 180 is 720 degrees. Okay, how did they get this formula? Where did they go? How did they figure this out? We based everything off of a triangle. If a triangle has 180 degrees in it, and you look at a quadrilateral is made up of 2 triangles. 180 plus 180 is 360. A pentagon, no matter where you draw the vertex from, is made up of 1, 2, 3 different triangles. 3 times 180 is 540. A hexagon is made up of 4 different triangles. 4 times 180 is 720. Now, if you want to know how many degrees there were in the interior angles of a pentadecagon, you don't want to have to draw a pentadecagon and then put all of its triangles in it and then multiply it times 180. You would be able to just say, all right, a pentadecagon has 15 sides. 15 minus 2 is 13. And 13 times 180, I'm going to calculate this. I always tell you to make sure you do it right. That a pentadecagon has 2,340 degrees in the sum of all of its interior angles. Well, if you draw it small enough or careful enough, it's going to start to look like a circle. But a circle is different because we don't talk about sum of interior angles. So, how many degrees, next question, are in the interior angles of a dodecagon? Here's where memorizing that list from the previous lesson comes in hand. If you have a question like this on a quiz or a test and you haven't memorized what your sides are, you don't know what a dodecagon is. So keep practicing that list and make sure you know it. Go ahead. Sum of the interior angles is 12 minus 2. Dodecagon is a 12-sided figure. Times 180. And 10 times 180 is 1,800 degrees in a dodecagon. Backwards. The sum of the measures of the interior angles of a convex polygon is 1,980 degrees. We'll always be talking about convex polygons as opposed to concave. Classify the polygons by the number of sides. So we're going to do the same formula, but knowing our algebra skills, we don't know the number of sides. We do know the answer. 1980 equals n minus 2 times 180. Your choice on how to solve this. Some of you will choose to distribute the 180. Others of you will choose to divide by 180 on both sides. If I take 1980, divide it by 180, You'll get 11. We're not done yet, though. It's not an 11-sided figure. 11 equals n minus 2 plus 2 plus 2. It is a 13-sided figure. Now it says classify it. If we know that n is 13, we now call it a 13gon. That's how we classify it. If it had 5 sides, we'd say pentagon. If it had 8 sides, we'd say octagon. But it is a 13gon. Next up, what if we knew all of these angles of that polygon except one? We needed to find x. First, we have to find out how many degrees are there total. So we'll start with 1, 2, 3, 4, 5. There's 6 sides, which also means there's 1, 2, 3, 4, 5, 6 angles. So I'm going to go with 6 minus 2 times 180, or knowing that it's a pentagon or a hexagon, we know that the sum of its interior angles is 720 degrees. Well, if we know that interior angles is 720 and we want to find just this angle that's left, I'm not going to write it all down, but it would be 720 minus each one of those. Go ahead and calculate that on your calculator. I got that x equals 113. 113 degrees for x. Next up, any equiangular polygon. Again, with the vocab, equiangular means that all the angles are congruent. Doesn't mean all the sides are, but all the angles are. It has to be equiangular for you to find one interior angle. Otherwise, we have no idea what one interior angle is because they could all be totally different. One interior angle equals the interior angle, capital I, n minus 2 times 180. That should look familiar. That's the sum of all the interior angles. Well, if you add them all up and get all the interior angles, you just have to divide it by the number of sides to find out what it is. Basically, it's the average. But you don't even need average because they're all the same size. How many degrees are in one angle of a regular octagon? One angle of a regular octagon. We want capital I for the one interior angle. Octagon, again, make sure you know how many sides an octagon is, which is 8. 180 divided by 8. 8 minus 2 is 6. 6 times 180 divided by 8. Go ahead and calculate that out also. And you get that one interior angle of any octagon that is equiangular is 135 degrees. So yes, your stop sign angles are all 135 degrees. Go check them. Backwards. If each interior angle is 140, how many sides does it have? Each interior angle is 140. Now we know the answer. Here comes our algebra skills again. 140 equals, we don't know how many sides it has. We have 2 ends. One variable, but in 2 different places. We're going to have to solve this. And of course, as usual, I'm going to show you the long way to do it, and then eventually, maybe later in the notes, I'll be like, ooh, try it this way. But here's the correct or the usual or the algebraic way of solving this. We don't want an n in the denominator, so we're going to cross multiply, just like we did with any other proportions that we've solved. 140n, we might as well go ahead and distribute this right away and do 2 steps in one equation. 180n minus 360. Once you do the cross multiply and distribute, this should just be a pretty commonplace 2-step solving equation for you. Minus 180n from both sides. Minus 180n. You'll get negative 40n equals negative 360. Negative divided by a negative is a positive, and 360 divided by 40 is 9. How many sides does it have? You can stop there because it said how many sides. If it said classify it, you'd have to call it a nonagon, but it just asked for how many sides. You go right ahead with the n. All right, moving on. Exterior angles. The sum of the exterior angles of any polygon, and if you remember, we did exterior angles in chapter 2 when we were doing a bunch of proof stuff. Don't worry, don't panic, we're not doing any proof stuff, although some of you kind of liked it. What is an exterior angle? It's basically if you took one side of the polygon and stretched it out past its polygon, there is an exterior angle. If there are 5 sides, there are 5 exterior angles. If there's 8 sides, there's 8 exterior angles. If there's 12, there's 12. And one might want to argue, like, oh yeah, there's 5 of them, and I'll go this way, and I'll go this way, and I'll go this way, and I'll go this way. But what if you then extended it this way? Well, now you've got 10 of them because you extended it both ways. Not true. You have an exterior angle right here going this way. You can't then extend it going the other way. Those are congruent angles. They're the same size. You get to pick one exterior angle at each spot. So if you choose this side and you go exterior angle this direction, you're not allowed also at this same spot to do a second exterior angle. Pick one or the other. If you pick the red one, this is its angle. If you pick the blue one, this is its angle. But if you notice, those are vertical angles. They're the same size anyway. So if you pick red and your boyfriend picks blue, don't fight over it. You're going to get the same answer. What happens if I add up all of those exterior angles on any polygon? Wait till you see this formula. The sum of the exterior angles is 360 degrees no matter what. It's 360 degrees. That's it. Done. No work to do. They're all exactly the same. Which means the measure of one exterior angle of any regular polygon, now it has to be regular, all sides and all angles are congruent, you're going to take that 360 and divide it by the number of sides. So we'll do a couple of examples. It tells you to find x. It shows you that all sides are congruent. Exterior angle x, they're all going to be the same size. X, all the way around. 360 degrees in all exterior angles. Divided by number of sides. 1, 2, 3, 4, 5, 6, 7. Divided by 7. X equals, it'd be nice if that was a whole number. I bet you it's not. 360 divided by 7. Not only is it not a whole number, but it's also not a terminating decimal. So you are going to not round it. You are not going to round it. You are going to make it a fraction. Reduced fraction as far as you can, which you can't. 360 divided by 7. That's how many degrees each one of those angles is. You can't round it, because if I rounded it to 51.4 and I multiplied that by 7, it doesn't add up to 360 degrees. So 360 over 7 degrees, it's about 51.5 degrees. Okay, what am I going to do with this one? Same idea, but notice now they're all different sizes. It doesn't matter. They still add up to 360 altogether. Okay, how many x's or how many sides do I have? 1, 2, 3, 4, 5 different sides. Okay, 360 divided, well, we can't divide it by 5. If we're going to divide by 5, that means that they're all the same size. We want to find out how big each one of these is. Altogether, they're 360 degrees. So let's find out how many x's we have. 1x, 3, 5, 9, 10, 11, 12. All together, all the way around the exterior angles, we have 12 x's. Divide by 12 on both sides, and we get x equals 30. Check and see if that works. Does x equal 30 work? That means this is a 30-degree angle. This is a 60-degree angle. 60, 120 degree angle, and a 90 degree angle. Add those up, adds up to 360 degrees. So x equals 30. All right, just in case you don't believe me, I gave you a formula that said all exterior angles, the sum of them add up to 360 degrees. If I drew each one of these exterior angles as close as I could, some of them are off by a little tiny bit, and I put them together, all of their angles, add it up, check that out. All together, those all add up to 360 degrees all the way around. That works for an irregular pentagon. If it works for an irregular pentagon, does it work for everything? Here's a hexagon, and it's actually a regular hexagon. There's 1, 2, 3, 4, 5. Oh, this wasn't a hexagon. This was my septagon that we had before. 6, 7, 360 degrees. Pretty cool, huh? Even this one, completely 100% irregular. We put them all together. I think you get the point. But it's one of the most common mistakes from geometry students. We ask you what's the sum of the exterior angles of any polygon, and you get it wrong because you think it's harder than it is. And really all it is 360 degrees. Every time, without fail. Okay, we have 2 examples left of our notes. In here it tells us the measure of one exterior angle of a regular polygon is 36 degrees. How many sides does it have? So you're going to take the formula for one exterior angle, which is 360 degrees divided by number of sides, and just say, all right, I already know the answer to this. It's 36. That's the whole idea behind algebra, is that we know the answer. We just have to come up with the piece of the problem. I need to find n, and in the same way that we had issues in trigonometry that you couldn't have the variable in the denominator, we have the same issue here. You've got to switch places with those. Let's get the n up on top by cross multiplying, dividing kind of all in one step. If you take 360 divided by 36, you'll find out that it is a 10-sided figure. N equals 10. Pretty much one easy step. 360 divided by n. Change places to divide. Next example, last one. The measure of one interior angle of a regular polygon is 144 degrees. How many sides does it have? So we go with interior angle of n minus 2 in parentheses times 180 over n, and we know that this is 144 degrees. Well, guess what? We already did one of those problems, if I can find it. Maybe it was here. Oh, there it was. So we already did one of those problems, and we solved it by cross-multiplying, distribute, subtract, divide. 4 steps. Cross-multiply, distribute, divide. But there actually is, I told you there was going to be a shortcut to this. Think about what an exterior angle is compared to an interior angle. If you have an exterior angle, and you know that the interior angle is 144 degrees, wouldn't it be much, much faster to work with the exterior angle? I mean, look at how simple this formula is compared to how obnoxious this formula is. If you found the exterior angle instead, it's still the same number of sides. That's a linear pair. They add up to 180 degrees, which means this is a 36 degree angle. Take 360 divided by 36, you find out that it has 10 sides. The alternative is to do the whole entire thing and say, I know that this is 144, I don't know n, but I'm going to cross multiply, distribute, subtract, get negative 36n is negative 360, divide, and you get 10. Okay, so the idea here is the understanding of if you know how an interior and exterior angle is related, you know that they're a linear pair. They're going to be every time. That's the whole idea behind exterior angle. Just subtract to find the exterior angle and divide it. Much, much quicker. That's it for your notes. I know, that's it. It was kind of a lot. Thanks for hanging in there. Bye.